Imagine a single seed. Now imagine billions of them. How do we plant them perfectly to feed our growing world without wasting a single drop of water or inch of land? What if the secret to solving global food scarcity lies not in more land, but in more intelligence? Welcome to the Fields of Innovation YouTube channel. Smart farming starts here. Discover the future of agriculture, where we share information about technology applied in agriculture. Today, we re-diving deep into one of the most exciting advancements in modern farming, how artificial intelligence is revolutionizing seed planting for maximum yield. The challenge ahead of us is immense. By 2050, our planet will be home to over 9 billion people. This explosive population growth puts enormous pressure on our food systems. Traditional farming methods, which have served us for centuries, are struggling to keep up. They simply cannot scale efficiently enough to meet this unprecedented demand, creating a critical need for technological innovation in agriculture. At the very heart of this challenge lies a fundamental problem: the seeding dilemma. When seeds are planted too close together, the resulting plants are forced to compete for essential resources like sunlight, water, and soil nutrients. This fierce competition leads to stunted growth, weaker plants, and ultimately, a lower harvest. Conversely, if seeds are planted too far apart, we waste precious land, water, and fertilizer. This delicate balance between density and efficiency has long been a major bottleneck in farming, a puzzle that farmers have tried to solve for generations. Now, a powerful new tool is emerging to crack this code: artificial intelligence. AI is poised to become the ultimate solution for this age-old problem. Unlike the human eye, which relies on experience and intuition, AI can process and analyze thousands of data points every second, from the texture of the soil in one corner of a field to the specific microclimate in another. AI can make hyper-precise planting decisions, turning guesswork into a data-driven science. In doing so, it positions itself not just as a technological marvel, but as a savior for our environment and our food security. To truly appreciate AI's impact, we first need to understand seed density optimization. In simple terms, seed density refers to the number of seeds sown within a specific area, like a square meter or an acre. This single factor has a profound and direct influence on everything that follows: the health of individual plants, the level of competition among them, and the total yield of the crop. Getting it right is crucial for a successful harvest. The ideal seed density isn't a fixed number. It's a dynamic variable influenced by a multitude of factors. The fertility of the soil, for instance, plays a huge role. Nutrient-rich soil can support a denser plant population than less fertile ground. The type of crop also matters, as a corn plant has vastly different space and nutrient requirements compared to a wheat or soybean plant. Furthermore, the availability of water through irrigation and the local climate conditions, including temperature and sunlight hours, all change the equation for ideal seed spacing. Traditionally, farmers have relied on established rules of thumb, almanacs, and their own invaluable hands-on experience passed down through generations. While this approach has its merits, it often leads to overgeneralization, treating an entire field as a uniform entity. In reality, a single field can have significant variations in soil type and moisture levels. This is where AI makes a quantum leap forward. By using real-time data from sensors and satellites, AI can adapt seeding strategies dynamically. It can command a planter to sow seeds closer together in a fertile patch, and then, just a few feet away, increase the spacing in a section with clay-heavy soil, all within the same field. So, how does AI actually perform this incredible feat of optimization? The process is a symphony of data, algorithms, and machinery. It all begins with comprehensive data collection. Sensors embedded directly in the soil continuously gather information on critical parameters like moisture content, pH levels, and nutrient composition. Meanwhile, drones and satellites fly overhead, capturing high-resolution aerial images. These images are analyzed to identify patterns that are invisible to the naked eye, such as soil compaction, subtle variations in elevation, and existing vegetation density. Once this vast amount of data is collected, it's fed into sophisticated machine learning models. These AI algorithms are designed to sift through the noise and detect complex correlations between a field's conditions and the resulting crop performance. For example, an algorithm might learn that loamy soil with a moderate nitrogen level can support a 15% denser planting of soybeans, whereas clay-rich, poorly drained soil requires a 20% reduction in density to prevent crop failure. These models are not static. They learn and improve with every new piece of data from each growing season. To take this a step further, many systems employ deep learning neural networks. These advanced models can run thousands of virtual simulations, testing different planting densities and patterns against the collected data to predict yield outcomes. This allows farmers to see the most probable result of a particular strategy without having to risk a single real seed in a physical trial. Finally, this optimized plan is put into action. AI-integrated machinery, such as autonomous tractors and robotic seeders, receives these precise instructions. With millimeter precision, these machines automatically adjust the planting depth and spacing as they move across the field, executing the AI's complex plan flawlessly in real time. This is the beautiful synergy of software, sensors, and robotics working together. This technology isn't just a futuristic concept. It's already delivering tangible results in farms across the globe. In the corn and soybean belts of the United States, major companies like John Deere and its subsidiary Blue River Technology are at the forefront. They use advanced computer vision systems on their equipment to identify optimal planting zones in real time and even to differentiate between newly sprouted crops and invasive weeds, enabling targeted action. In Canada, farmers face the challenge of vast, uneven terrains. Here, AI-driven predictive models are being used to analyze landscape data and forecast wheat yield variations. This allows farmers to allocate their valuable seeds more efficiently, ensuring that every part of their land is used to its full potential. Down in Australia, where drought and water scarcity are constant threats, AI is a critical tool for survival. Farmers use AI systems to calculate the perfect planting density that maximizes water use efficiency, ensuring a viable crop even with limited resources. And in the United Kingdom, innovative agri-tech startups are combining robotics and AI to develop eco-friendly planting methods. These techniques minimize soil disruption, which helps preserve soil health and maintain local biodiversity, proving that high-tech farming can also be sustainable. The benefits of AI-optimized seeding are far-reaching, touching on both economic viability and environmental responsibility. One of the most immediate advantages is a significant reduction in input waste. By planting seeds with surgical precision, farmers use fewer seeds overall and can apply fertilizers and other treatments more efficiently. This directly translates to lower production costs and a healthier bottom line. Beyond cost savings, this precision leads to higher, more uniform yields. When every plant has the ideal amount of space to grow, it develops a healthier root system and receives adequate sunlight and nutrients. This results in consistent crop development across the entire field, making harvests more predictable, profitable, and of a higher quality. Environmentally, the conservation of resources is a major win. Optimized planting strategies save immense amounts of water, as irrigation can be targeted more effectively. It also reduces energy consumption, as machinery operations become more efficient. On a global scale, this technology is a powerful tool for bolstering food security. As climate change introduces more unpredictability into our weather patterns, AI's precision-based approach helps ensure stable and resilient food production, even in the face of challenging conditions. Of course, like any transformative technology, the adoption of AI in agriculture is not without its challenges and limitations. The entire system is built on data, and the old adage, garbage in, garbage out holds true. The AI is only as good as the data it's trained on. Poor quality, incomplete, or regionally biased data can lead to inaccurate predictions and flawed recommendations, potentially costing a farmer an entire season's crop. Another significant barrier is the high cost of implementation. The advanced sensors, drones, autonomous machinery, and data infrastructure required for these systems are still very expensive. This puts the technology out of reach for many small-scale farmers or those in developing nations, creating a potential digital divide in agriculture. Finally, there is a knowledge gap. Fully utilizing these powerful AI tools requires a new set of skills and a degree of digital literacy that many farmers do not yet possess. Bridging this gap will require a concerted effort in education, training, and public-private partnerships to make the technology accessible and user-friendly for everyone. Looking ahead, the future of AI-driven farming is incredibly bright and points toward ever greater autonomy and intelligence. The next generation of smart farms will feature a seamless integration of deep learning, the Internet of Things, IoT, and advanced robotics. Imagine a farm where soil sensors, scouting drones, and planting robots are in constant real-time communication, all coordinated by a central AI that orchestrates their every move. This future AI will move beyond reaction to proactive, predictive adaptation. It will be able to forecast potential problems like soil fatigue, emerging pest threats, or impending rainfall shortages days or even weeks in advance. Based on these predictions, it will automatically adjust seeding plans and resource allocation before the problems can even take root. This evolution leads to the ultimate vision, fully autonomous farms. These are self-operating agricultural ecosystems where machines and algorithms are in a perpetual cycle of learning, adapting, and optimizing, all without the need for constant human intervention. In conclusion, artificial intelligence is fundamentally transforming the art of seeding from a practice of guesswork and tradition into a precise, data-driven science. By optimizing every single seed's placement, AI is unlocking new levels of productivity and sustainability. This isn't just about growing more food, it's about growing it smarter. Precision farming, powered by AI, is one of our most promising keys to feeding the planet responsibly in an age of growing scarcity and environmental challenges. We hope this video has given you a glimpse into the incredible future of agriculture. What are your thoughts on AI in farming? Do you see it as a solution, or are you concerned about the challenges? Share your thoughts, experiences, and any questions you have in the comments below. And if you want to keep exploring the cutting edge of agri-tech, don't forget to like this video and subscribe to Fields of Innovation for more. Thank you for watching.